For our second lesson, we're going to be looking at polynomials and how we can multiply them. So we're going to be taking all of the information from our first lesson and we're going to be combining it with some other previous skills we know. So the first thing we're going to do is we're going to practice multiplying a monomial by a polynomial. So just as a reminder, a monomial is a polynomial that only has one term, and then a polynomial is where I have multiple terms added or subtracted together. So when I have something like this 3x being multiplied by a polynomial, I have to distribute it in. So we're going to draw our arrows and multiply it by everything in the bracket. So remembering your exponent laws from lesson 1, my x multiplied by an x, we're going to add those exponents. So we'll have 3 times 2, which is 6, and x squared. And then we have 3x multiplied by y. And then we have 3x multiplied by 7, which will give us 21x. And then we always want to make sure that we put all of these in order. So we keep them with our highest exponents at the beginning, and then everything else is alphabetical. So for our second example, we're going to multiply in this 5x to the power of 7. So we'll draw our little arrows. So we first start by multiplying our coefficients. So 5 times 1 is just 5. And then we'll multiply our x's. So x to the power of 7 multiplied by x to the power of 2. We keep our x, and then we add our exponents. So 7 plus 2 will give us 9. For the next term, 5 times -1 will give me -5. And then I multiply my variables, x to the power of 7, y to the power of 2. And then finally, 5 times 5 will give me 25. And then our x to the power of 7 just comes along with us. And again, we should write these in the proper order. It doesn't make a huge difference right now, but moving forward, it will make a huge difference. So that's a bit of a recap from grade 9. Now we're going to take this one step further and do the grade 10 version of this. So in this case, we're going to be multiplying two binomials. So in this case, we need to make sure that everything gets multiplied. So we have this a over here, and that needs to get multiplied by everything in the other bracket. So a is going to be multiplied by c, and then a is going to be multiplied by d. Once we've done that, we also need to make sure that b gets multiplied by everything in the other bracket. So we'll have b multiplied by c and b multiplied by d. Similar to when we're using our distributive property, it's very important that we draw our arrows. If you forget to draw your arrows, it's very likely that you'll make a mistake. So that's the first way to remember this. The second option is we can use the acronym FOIL. And FOIL stands for first, outside, inside, last. And how you use that, I'll show you using that first example again. So for first, we take this A and we multiply it by C. That's the first thing we do. Then the next one is outside. So what outside means is we take our A and we multiply it by that D that's on the outside. So we take those two outside things and we multiply those together. Then we have inside. So that's this little inside part with the B and the C. And finally, we have last, which is B and D. It's up to you if you prefer the first option with just the arrows, or if you like the acronym. It doesn't matter, as long as you make sure you've multiplied everything there only once. So we're going to do a few practice ones, and we're going to expand. So that multiplying out part where we do the arrows, that is referred to as expanding. And then we will simplify where we collect like terms. So anytime you're given something in brackets like this, we always want to expand it out and then simplify it back down. So for this first one, we'll start by drawing our arrows. So 2x multiplied by x will give me 2x squared. 2x multiplied by 4 will give me 8x. And now we need to multiply this 3. So 3 times x, 3x. And then 3 times 4 is 12. So that's our expand part. And the next thing we need to do is our simplify part. So now we're going to look for like terms. So just as a reminder, like terms are the terms that have the exact same variables. Order of letters doesn't matter, but it has to have the same letter raised to the same exponent. So here I have an 8x and a 3x. So I can combine those two like terms. And now, because all of my terms aren't like terms, I know I'm done, and that's where I stop. So for the next one, we're going to do the same thing. We're going to take this 4x and multiply it by the 2x. Then we multiply it by this -1. And now we need to deal with the 3. So the -3 gets multiplied here and multiplied by my -1. And similarly, I'm going to have to collect some like terms here. So those two terms that have an x, I can combine those. And then, because I have no more like terms, I know that I am done. So my next example, we're going to start going through them a little bit faster here. Multiply my 5 in, and then multiply this 3 by everything. And now we're going to collect some like terms. So we're going to rewrite this. And then collect those like terms. So this is where you can see the order of how we write it makes a very significant difference. Last one on this page, so we're going to multiply that x in. And then multiply the 4 in. It's a good idea to always keep your variables alphabetical. It just helps you to identify like terms. Highlight my like terms. Okay, so let's try a few more examples. They're going to get a little bit trickier. So this one here, we have 3 multiplied by x minus 5 all squared. So as a reminder, when we square something, we're just multiplying it by itself. So we have 3 x minus 5, and that is just multiplied by itself. So we always work with the brackets first. So we're going to do the exact same steps, and we'll just leave this 3 hanging out for a while. And now we'll collect our like terms here. And finally, we can multiply in that 3. Just save it for last, because if you don't, there's a good likelihood that you'll accidentally multiply it in too many times. Okay, our next example, same idea. We're just going to leave that 3 on the outside and we'll deal with it after. And now we'll multiply those brackets. We'll collect our like terms. And finally, we multiply in that 3. Oops. Okay, 2 more quick examples. So these ones get a little more challenging, but the same ideas apply. So we'll work on C first. So the first thing we're going to do is we're going to write out that 2x plus 3 all squared. So again, when it's squared, it's just 2x plus 3 multiplied by itself. And then we haven't done anything with the other part, so we'll just leave it there. And now we're going to multiply our binomials. Multiply that one. So be careful with this little negative over here. We have to deal with it similar to how we dealt with that 3 before. So we leave the little negative on the outside, and we'll multiply all of this like normal. Now we'll quickly collect some like terms inside these brackets here. Just to simplify things before we start multiplying again. And now, just like we did above, we have to multiply in that negative, just like how we did with the 3. So be very, very careful with these little negatives here. It's very easy to miss them. So it's a good idea to highlight it something so you don't forget to multiply it in. And now we can finish collecting our like terms. So we'll put all of our x squareds together. I'm just going to rewrite them out in order, just so that we don't miss any by mistake. And then that's our final answer. So we'll try one more over here. So same idea, we're going to start by multiplying out our brackets. So again, be very careful that we don't have any negatives there. So because we don't have negatives, we don't need to worry about everything that we had to in the first one. So this will give us 3x minus 2x squared minus 3 plus 2x. And then we'll do the same thing over here. And now we need to start collecting our like terms. So we'll start by putting them in order. So we'll start by looking for all of our x squareds. And then our x's. And finally, our constants. And now that they're all in order, it makes it very, very easy to combine like terms. And that's it. So when you keep practicing these, you'll get good at being able to find your like terms and being able to identify them and combine them really carefully. So our last example is going to be an application question. So a square has its length increased by 3 centimeters and its width reduced by 5 centimeters. We want to write an expression for the new area. And it gives us a little let statement, which is nice. So let x represent the length of the original square. So we'll start by drawing our original square here. And it's telling us that my length and width are all x. It's a square, so we know that they're all the same. So for our new square, which isn't going to be a square anymore, we know that our length has been increased by 3. So over here, we had whatever our length was, and we increased it by 3. And then our width was reduced by 5. So whatever our old width was, we reduce it by 5. So we're going to take those new dimensions and write them over here. So my new length is whatever the old one was, plus 3. My new width is whatever the old one was, minus 5. So now we can plug all of this into our area formula. So my area is length times width. So my length is x plus 3, and my width is x minus 5. And now I'm going to multiply those brackets. And because we had words in the question, we need to make sure we write a nice therefore statement. So therefore, the new area is x squared minus 2x minus 15.